All right, we want to solve the following system using substitution method. So the first part of substitution method is solving one of the equations for one of the variables. So the second equation is really easy to solve for y. It's got a coefficient of 1, so all I need to do is subtract 2x from both sides. And I get y equals negative 2x plus 3. So after we do that, we're going to then substitute the expression for y, this negative 2x plus 3, into the other equation. So when we do that, we're going to get 3x plus 4 times, and then that expression for y, which is negative 2x plus 3, equals negative 8. So now we'll solve this for x. So just multiplying through 3x, we have a negative 8x distributing through by 4 plus 12 equals negative 8. We had a negative 5x, and then we'll subtract 12 from both sides. We get equaling negative 20, and then dividing by negative 5, and we get x equals 4. So as soon as we have one of our solutions, we'll back substitute and find y. So in this case, y then would equal negative 2 times 4 plus 3. So we'd have y equals negative 8 plus 3, or y equals negative 5. So the solution is an ordered pair, and the ordered pair would be x, y, or 4, negative 5. All right, for the next problem, we want to solve using the elimination method. So the elimination method is done by adding. So the first thing I'm going to do is just put my system in a form that we can use when we add. I'm just going to put all my variable terms on one side and then equaling the constant. So the top equation will add 6 to both sides to get this equal to 6. The bottom equation I'll have 8x, but then I need to get rid of or move the y term over. So I'll subtract 9y from both sides, and then that equals negative 18. So the idea with the elimination method is that when I add the two equations together, I'm going to cancel or eliminate one of the variables. So in this case, what I can do, if we notice, the y terms are opposites. If I multiply this y term by a factor of 3, I would end up with 9y. So what I'll do is I'll multiply the equation on top by 3, both sides, and I'll end up with a system 15x and then plus 9y, and that equals positive 18. So the bottom equation stays the same, but now my y terms are opposites of each other. So now I should be able to add the equations together, and it will eliminate the y terms. So I end up with 15x and 8x is 23x. The y terms eliminate, and then equals 18, and negative 18 is 0. So we'll solve this for x, dividing both sides by 23. We actually get x equals 0. So that's one of our solutions. We'll just back substitute. Maybe we can go back into the first problem. We'll back substitute to find, in this case, y. But I plug in, I'd have 5 times 0 plus 3y minus 6 equals 0. I'd have 3y equals positive 6, adding 6 to both sides. Of course, 5 and 0 is 0. And then dividing by 3, we get y equals 2. So our solution then would be x, y are 0, 2. So the last equation, or the last system that we want to work with here we could use either method we want, but before we do want to simplify. So if you notice, the top equation is fractions, so we can clear fractions by multiplying both sides by a factor of 10. And by doing this, we'll end up with what system? So the right side, when I multiply by 10, this is one term. So the 2 would cancel, leaving a factor of 5 that needs to be distributed. So the 5 is distributed to 4x and negative 3y. So I'd end up with 20x and then a negative 15y. On the right side, the 5 and the 10 would cancel, leaving a factor of 2. So our first equation is 20x minus 15y equals 2. The bottom has decimals, and we can clear decimals. In this case, the decimals have 2 places. So if I multiply both sides of this equation by 100, we can clear decimals. So by doing this, we can distribute. If I multiply by 100, the decimals move over 2 places. I'd be left with just 20x. If I distribute the 100 here, I'd be left with a negative, and then move the 2 decimals, 15y, and then that's supposed to equal 2 times 100, which is 2. And if you notice, we have exactly the same line. We don't have to do any more algebra to see this. If we did multiply the top by -1 and add, we would get, so if you multiply the top by -1 and add, we would get 0 equals 0, which is an identity, which basically says that the lines are the same. So if the lines are the same, then the solution is infinite ordered pairs, or infinite solutions on the line.